Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone and welcome back. In this lecture, we're beginning our look at how to analyze and visualize stock returns with the Python libraries Pandas and NumPy, as well as PyPlot. Starting off, we're going to learn how to visualize stock prices with PyPlot and load in stock data. So first, we need some stock data to visualize. For that, join me in Google Colab and we're going to load in data. In a code cell, we're going to access the console and then use pip to install the Finance library. Then we're going to import Yahoo Finance into this file. That way we can put it to use. So we can download our data from Yahoo Finance, and what will get returned is a Pandas data frame. So I'm going to create a variable called data and use yfinance.download. Here I'm going to pass in the name of my stock symbol, like XRP-USD for the XRP coin. We can also pass in a start date like 2018-0101 and an end date like 2022-0101. Then we can run this code cell and we can inspect the data by calling the head function. This will give you the first 5 entries, and you can call data.tail to get the last 5 entries. As well, you can get data.info to get information about the data frame overall. So we can see this is a Pandas data frame, and we can see the columns, the number of null values, and the data types, as well as the memory storage. Next, we can visualize this data with the library PyPlot. So I'm going to create a new code cell, and I'm going to import matplotlib.pyplot as pyplot. And I'm going to call pyplot.plot, and we can take our data and plot one of the columns, such as the high price. Then we can run the code cell, and here we have our visualization. Now we can format this graph to be a little easier to read. For that, first off, we can set the figure size. We can change the figure sizes of all of our plots at once by using pyplot.rc_params and changing the figure.fig size property to something like 20 by 10. Then we can run the code cell, and here now our graph is bigger. We can also update the font size, so changing the text size of the graph. For that, we're going to call pyplot.rc_params, and we're going to use the update function for font.size and set it to 18. Then we can run the code cell, and now our font size is bigger. So what is this graph anyway? Well, on the y-axis, we have the price of the stock. So we can add that to our actual graph. Okay, we have the prices of this stock. So let's add the y label. For that, we can call pyplot.ylabel and set this to high price. Then if we rerun the code cell, we'll have that added to the label. All right, so in this way, we can visualize our data. And you can see in 2018, we had a peak. Then we had a dip all the way to 2021, at which point the price started to climb. And now it's quite volatile. Right, so we can see the trends in the data, and we can also see what the price was at a certain date. Join me coming up next. We're going to learn how we can calculate yearly returns on our stock with Python. Hello everyone and welcome back. In this lecture, we're going to learn how we can calculate yearly returns on our stocks with Pandas. So join me back in your project where we have our data frame of prices per date. We're going to create next up a yearly variable to store our data sets per year, yearly returns. So for this, we can grab our data and use the as frequency of by. And then we can inspect the yearly variable. Right, so here for yearly, we have 2018, 2019, 2020, and 2021. So here we have by year as the frequency. We have the open, high, low, close, adjusted close, and the volume for each of our years. Next, how can we calculate the returns per year? Well, for this, we can take our yearly data and create a new column, returns. We'll take our original data at the closing price and use the percent change function in order to calculate the returns. Then we can inspect the yearly data frame again. So this time we have a returns column that's been added. As well, we can reset the index of the yearly column with yearly equals yearly.reset index. Then we can inspect the yearly data frame again. So this time, our date index column just becomes its own column. As well, we can grab our years and create a new column. So in the yearly data frame, we're going to create a new column called years. And for that, we take the date and use datetime.year. Then we can inspect the yearly data frame again. So we have this extra column added called years. All right, so that way we can just extract the years from a date. Because if you remember, we can call yearly.info to get information about each column. And the date column is a date time type. So from a date time type, you can access the year. So now let's visualize our yearly returns. For this, I am going to use pyplot. So I'm going to call pyplot.bar to create a bar plot. I'm going to grab the years and grab the yearly returns. Just make sure you put the name of the column into a string. And we can run our code cell. This will create a bar plot. On the y-axis, we have the returns. So we can add to the plot, call pyplot.ylabel, and add returns to the y-axis label. On the x-axis, we have the year. So from 2017 to 2018, from the half of 2017 to half of 2018, we can see that our returns were around negative 0.04. Then for 2019, our returns were negative 0.01. For 2020, our returns were 0.04. And for 2021, our returns were negative 0.01. Okay, so here we can inspect our returns per year. Right, so in this way, we can calculate how much of a return we have each year. That does it for this project. I'll see you in our next project. Hello everyone and welcome back. In this lecture, we are introducing our upcoming project, Stock Portfolio Analysis with Python. First, we're going to build a stock portfolio and then calculate its performance with Python. Then we're going to visualize our cryptocurrency portfolio returns with pyplot, which is a plotting library in Python. Then we're going to analyze our portfolio returns with data science and calculate our expected cryptocurrency returns with pandas. So for this process, we're going to calculate properties like standard deviation, skewedness, kurtosis. We'll get into a lot of those different properties later on. For example, the standard deviation, how much the actual return is likely to differ from what you expect to get, how much a price quote varies from an asset's average price. The higher the standard deviation, the more volatility and price fluctuation, therefore the more risks you have with a trade, but also the more profit and loss opportunities. If you have a low standard deviation, there are fewer trading opportunities. The formula for standard deviation is to take every return over a time period, find the average, subtract the average from each return, square the difference, average the sum of squares, and calculate the square root. But luckily for us, with the Pandas library and other libraries, we can calculate these different properties like standard deviation, kurtosis, skewedness really quickly. So you'll see how handy Python is. Then we're going to visualize our stock drawdowns with Python. So an exciting project throughout for the drawdowns, we'll use the Pandas library, which has helpful features like using rolling to calculate the rolling window, where you take a window size and perform a mathematical operation on it. This window size is consecutive values of a number of days. And so we're going to go from building our portfolio to analyzing the data, visualizing it, projecting the returns, and the drawdowns. So this is a great beginner project for learning how to analyze a portfolio with Python. I'm excited to get started, so don't miss the next lecture. Hello everyone and welcome back. In this lecture, we're beginning our project of stock portfolio analysis with Python. Our first step will be to build a stock portfolio. So join me in Google Colab, colab.research.google.com. We're going to get started in a new code cell. First, we're going to install the Finance package. This is going to allow us to use Yahoo Finance to scrape data. Then I'm going to import the Finance package. Next up, I'm going to create a data variable to store our data. For that, we use Finance and call the download function to download some data. Here I can pass in the stocks that I want to get, followed by a start date like 2020-01-01 and an end date like 2022-01-01. And we can grab a certain column like the closing column. Now, what should be our stocks? Well, you can pass in any list of stocks here that you'd like, such as BTC-USD, as well as ETH-USD, Doge-USD, and Matic-USD. Then you can run your code cell, and once the download is complete, you can inspect your data. For example, the first 5 entries you can inspect with the head column, with the head function. So here we have the date followed by the closing price for each of our 4 stocks. So this will represent our stock portfolio. Okay, now we can also calculate the daily returns of each of our stocks. For that, I'm going to create a new code cell. I'm going to create a returns variable, which will take my data and use the %change function on it. Then we can call returns.head to inspect our results. The first row is nan because you can't calculate returns if you don't have a previous day. But then for all the other days, we have the returns now. So previously we had the closing price, but now we have the returns. So we have a different data frame this time. We can also drop our null values by overriding the variable with the drop NA function. And then we can inspect the returns data frame this time. So we just removed that first row, which had a null value. So this will be our stock portfolio. We have our stocks and we also have returns calculated. Coming up next, we're going to learn how we can calculate the portfolio's performance. So don't miss the next lecture. Hello everyone and welcome back. Previously, we created our stock portfolio. In this lecture, we're going to calculate our portfolio's performance. So join me back in your project. We are going to calculate our average daily returns by taking our returns and using the mean function. Then we can print out the value of our average daily returns. So for Bitcoin, we have 0.003. For Doge, we have 0.01. For ETH, we have 0.006. And for Matic, we have 0.01. Next, we're going to calculate the sample standard deviation. This will measure the dispersion of the dataset relative to its average, and it's calculated as the square root of the variance. If data points are further away from the average, there's a higher deviation. Therefore, the data is more spread out and there's a higher standard deviation. So this will give us insight into the stock's historical volatility. So to calculate the standard deviation returns, we're going to create a variable called standard deviation daily returns, and we use returns.std. Then we can print out the value of the standard deviation daily returns. So for Bitcoin, we have 0.04, Doge 0.16, ETH 0.05, and Matic 0.09 approximately. Right, so here we can calculate that dispersion of the data set. As well, let's calculate the portfolio weight. This is the percentage of our portfolio that a particular asset has. So we can divide the dollar value of the stock by the total dollar value of the portfolio. So let's define the weights for our portfolio. We're going to create weights and use the numpy.array function. And let's specify our weights. So for Bitcoin, let's say we have about 30% of Bitcoin. For Doge, 1% or 10% rather. For ETH, let's say we have 60%, so 0.6. And so that leaves us with nothing for Matic, so we'll have to change this up, 0.5 for ETH and 0.1 for Matic. So in total, you should add this up to be 1 because it's 100% represented as a decimal. So we have 30, 40, 90, 100. So these will be the weights for each of our stocks. Now we're using NumPy, so we do have to import the NumPy library in order to use the NumPy array type. Next, we're going to calculate the pairwise covariance of our columns. Covariance evaluates how the average values of variables move together. If Bitcoin's stock return moves higher whenever Doge's return moves higher, and Bitcoin's moves lower whenever Doge's moves lower, if the returns have that correlation, then the stocks are said to have positive covariance. So let's calculate a covariance metric using our daily returns. Let's create that covariance matrix, and we're going to use our returns.cov function. Then we can multiply the values by 250. And let's print out our results of the covariance matrix. All right, so Bitcoin to Bitcoin, we have the covariance. Bitcoin to Doge, we can see the covariance. And same thing in the opposite direction, they have the same covariance. Okay, so here we have the average values, we have the calculation of how the average values of the stocks move together. All right, so we can see we have positive covariance for our stocks. Next, we can calculate the expected performance of our portfolio. So for this, we're going to create a variable expected portfolio performance. For that, we use numpy.sum to get the sum of our average daily returns multiplied by our weights. Then we can print out the expected portfolio performance. Okay, so we have 0.006. That is our portfolio return. Let's add a portfolio returns column to our returns data frame. So we'll create here portfolio returns, and we'll use returns and use the dot function, which is multiplication, to multiply the returns by the weights. Then we can call returns.head to inspect the first 5 values. So here we have the returns in our whole portfolio. So for each of the 4 columns, first we have the returns per stock. Then we have the total returns, which takes each return and multiplies it by the weights, the dollar value of how much you've invested into each of these stocks. As well, we need to calculate cumulative returns. For that, we're going to create a variable daily cumulative returns. We take 1 plus our returns, and we use the cum_prod function. This stands for cumulative product over our data frame. And then we can print out our daily cumulative returns. So the daily cumulative returns come in the form of a data frame, so you can access the head function. So here we have our daily cumulative returns. So what this is calculating is over time, how much do you have in returns? So you can start at the beginning and then you can check out the tail or end of the data frame and see where you finish off with each stock in terms of the returns. Right, so that is how you can calculate your stock portfolio performance and your cumulative returns. Coming up next, we're going to make this visual and visualize our portfolio returns. Hello everyone and welcome back. Previously, we built a stock portfolio and we analyzed the returns. In this lecture, we're going to visualize our crypto portfolio returns with the PyPlot Python library. First, we can take our returns and we can grab our portfolio returns column and inspect the histogram of that actual column. So the histogram shows you the distribution. If you want to make your plots bigger, then you're going to have to import matplotlib.pyplot as pyplot, the plotting library. Then call pyplot.rc params and change the figure.fig size. And pass in a size that you want for your plot, like 20 by 10. All right, so you can also increase the font size by calling pyplot.rc params.update and updating the font.size to something like 18. Then rerun your cells and you can see now on the y-axis here you have the distribution. So you can set your y label with pyplot.y label distribution. So this tells you the number of entries that had a certain return. So on the x-axis, we can set pyplot.x label. This is your returns. So your returns are on the x-axis and you have distribution on the y. So you can see where your returns mostly fell. So mostly the returns fell at around negative 0.1 and positive 0.1 between these two. Right, so in this way, we can see the distribution of our returns. Next up, let's plot our cumulative returns. So I'm going to create a new code cell. And here I'm going to create a figure and axes variables from pyplot.subplots. Then I'm going to call axes.plot and I'm going to plot my daily cumulative underscore returns dot index, and then followed by my daily cumulative returns at the column of portfolio returns, and close that function. We'll see this plot being drawn. On the y-axis we have the portfolio returns, and on the x-axis we have the date. So what is the y-axis? The y-axis refers to the cumulative returns. So you can set the y label of this plot just like we did before. The y label is going to be the cumulative returns. So I can rerun this code cell and we have cumulative returns. Then again, on the x-axis we have the date. So we have from 2020 to 2022. We can see our cumulative returns climbed over time, and then they had some volatility as well. All right, so in this way we can visualize our portfolio's performance. Join me coming up next where we're going to analyze more about our returns. Hello everyone and welcome back. Previously we built a stock portfolio and we calculated our stock portfolio performance with Python. Then we visualized our portfolio returns. In this lecture, we're going to analyze our portfolio returns with Python data science. So join me back in your Colab project. Let's calculate the average returns of our portfolio. For this, we're going to create here average underscore returns, using our returns data frame at the portfolio returns. Then here we can use the average function, or rather the mean function. Then I'm going to print out the average returns, and we get 0.006. So what does this mean? Well, this refers to the percentage as a decimal. So if we want to get the percentage value, we can take average returns times 100. Then we can print out the average returns as a percentage. All right, so as a percentage, we have 0.64. What about the standard deviation? We can calculate that as well. So for that, let's create standard deviation portfolio. To calculate the standard deviation, we take our portfolio returns and we use the std function and then multiply by 100 to get the percentage. So then we can get the standard deviation of the portfolio, 4.9. Next up, let's print out or calculate the skewness of the portfolio returns. Skewness measures the perceived tail risk. Tail risk is a change in the price of a stock that would place it on either the tail ends or the far edges of the normal distribution curve. If you have a higher rating, the perceived tail risk is higher, and there's a higher chance of a black swan event, which is an unpredictable event that is beyond what is normally expected. So let's calculate that skewness. I'm going to create a variable skewness and use the returns at the portfolio returns and call the skew function. Then I can call print on the skewness. Okay, and we get negative 0.09, so about negative 0.1. We can also measure the kurtosis, a measure of whether the data is heavy-tailed or light-tailed. A data set with high kurtosis will tend to have a heavy tail or outliers. Data sets with low kurtosis tend to have light tails, which means a lack of outliers. For us as an investor, the high kurtosis of returns implies that we will experience occasional extreme returns, either positive or negative, that are more extreme than usual. So let's create another code cell and let's calculate the kurtosis using the returns at the portfolio returns and then using the kurtosis function from the pandas library. So we can print out the kurtosis 13.9. All right, so that is going to give us the kurtosis of our data. Next up, let's calculate our total return and the annualized return from the price data. So for that, I am going to create a new variable called the total returns. I'm going to take my returns at the portfolio returns and take the last value, then subtract the returns at the portfolio returns, the first value. So this is going to give me the difference. So I can actually store the difference in its own variable to be more clear. So here we have the difference in our returns. Then we can take the difference and divide it by the returns at the portfolio returns at index 0. Then we can print out the total returns. Negative 1.95, so about negative 2. Next, let's calculate the annualized volatility from the standard deviation. I'm going to create here volatility and take my returns at my portfolio returns using the standard deviation and multiplying by numpy.square root of 250. And for this, we do have to import the NumPy library. Then we can print out the volatility value, 0.8. Next up, let's calculate our portfolio's variance. For that, I'm going to create here a variance variable, use numpy dot. Here we need the weights of our portfolio, and we're going to transpose the weights and multiply them by numpy dot dot, passing in our covariance matrix and our weights. Then we can print out the value of our variance formula result. And just make sure here you pass in numpy one time. Rerun the code cell and you'll get your variance. Here we have 0.61 as our variance. And that is how you can calculate variance. So in this lecture, we did some data science on our stock portfolio. Coming up next, we're going to calculate our expected returns some more using some more data science. So don't miss the next lecture. Hello everyone and welcome back. Previously, we built a stock portfolio and analyzed its performance. In this lecture, we're going to continue calculating our expected returns from the portfolio with the Python Pandas library. Let's create a new column in our data frame that calculates our negative returns. So I'm going to create a variable negative returns and use our returns data frame dot location of where the returns at the portfolio returns column is less than 0, which means we have negative returns. Then we can take negative returns and inspect the head of that data frame. So this time we only have negative values. Next up, we're going to calculate the expected return and standard deviation of these negative returns. So I'm going to calculate here the expected negative returns with returns at the portfolio returns using the mean or average function. Then we can print out the expected negative returns, 0.01. As well, let's calculate the standard deviation. So we'll say standard deviation of the negative returns. For that, we're going to take the negative returns and use the function std. Then we can print out the standard deviation negative returns. So we get for each of our columns, and we get, including all the currencies and the portfolio returns, the standard deviation of the negative returns. As well, let's calculate the Sortino ratio with the formula for the Sortino ratio. For that, we take our expected negative returns. We're going to subtract an RF value like 0.01, and we divide by the standard deviation of the negative returns. Then we can print out our Sortino ratio. So for each of our columns, we get the Sortino ratio. Right, so in that way, we can calculate our expected returns for our negative returns where we had only a negative value. Coming up next, we're going to continue the project and do more data visualization. So don't miss the next lecture. Hello everyone and welcome back. Previously, we built a stock portfolio and did data analysis on the portfolio. In this lecture, we're going to continue visualizing the analysis of our crypto portfolio. We're going to visualize the drawdowns, which shows the peak to trough decline during a specific period for an investment or a portfolio. So first, we need to calculate the rolling max value. So let's create here rolling max. For that, we take our returns at the portfolio returns and we use the rolling function. Here we're going to pass in center, true or false, the minimum period such as 1, and a window such as 250. Then we're going to get the max from this rolling max. So we can run the code cell and then inspect what is our rolling max result. Okay, so we get here a data frame, so we can grab rolling max dot head to get our first 5 values. Okay, looks like we just get a series instead. So we are going to actually just print out the rolling max. So we get the rolling max for each day. Next, we can calculate the daily drawdown relative to the max. So I'm going to create here daily drawdown using my returns at the portfolio returns divided by the rolling max minus 1. Then we can print out our daily drawdown. So we get the daily drawdown for each of our dates. Next, let's calculate the negative or minimum daily drawdown. So for this, I'm going to create here the negative daily drawdown and use the daily drawdown.rolling function, grabbing my center, true or false, my min periods, my window should be the same, and then we're going to get the min function, whereas previously we had the max. So then we can print out the negative daily drawdown. Just make sure here you pass in min periods equals 1. Then we can call print on the negative daily drawdown. Okay, so we have a bunch of data frames now, but to really understand this, we have to visualize the results. So I am going to call pyplot.plot, plotting my returns.index versus my daily drawdown. Then we can run our code cell and we get this graph returned. So on the y-axis, we have our daily drawdown. On the x-axis, we have the date. Next up, let's add our negative daily drawdown. So for that, I'm going to call pyplot.plot, this time passing in my negative daily drawdown. This is going to add an extra line to the graph in a different color, like orange. And what you see is for each of our time frames, from a minimum to a maximum, we show the maximum daily drawdown, or the minimum, the very lowest, in the time window. So here we can see in the time window from 1 to 250, where was that lowest point? Remember, the drawdown is the peak to trough decline during this time for the stock. Right, so that is how you can visualize your drawdowns with Python.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.